Okay, the idea of this video is going to talk about scatterplots and best fit lines. But in order to address what a scatterplot is or a best fit line, the first thing we want to do is address a simple idea of how do you take 2 points and make a line. All a best fit line is going to be is using more points to make a line that models our data. So if we can do it with 2 points, we should be able to do it with more. So the first thing we want to do is read through our problem here and realize that we want to set up 2 points. So I'm going to set up a couple XY coordinates saying that when we have a cost to buy 200 square feet of storage space, so 200 can be our input, we can get that storage space for $60. So there's our output. At the same time, we can get 325 square feet for $160. So there's our second coordinate point. And then we can go on our graph here and we can plot those points. So looking at 200 and 300, maybe we'll count by 50s. Call this 100 and 200, 300, 400 here. And we can plot the points. Then 60 to 160, my guess is we're going to want to top out at about 200 then. So halfway up will be 100, and we're essentially counting by 20s. So that means that we're going to go up to 200, 60, and 325, so halfway here, and up to 100, 120, 140 is 160. And essentially we've got a nice graph that we can draw a line through. And assuming that our model holds, we just need to come up with an equation for those 2 points. Now we've done that previously, so take a second, pause the video, and come up with your slope and your y-intercept and see if you can't find the equation for our line. Alright, so I found the slope here to be 4/5. Then I went and found a y-intercept of negative 100. I also went ahead and filled in the final questions. Interpret the meaning of the slope. Well, the basic idea is remember that the y-coordinate deals with the cost. So every 5 feet, the bottom of our fraction, every 5 square feet of space will essentially cost an additional $4. Or you could say something about the dollars per square foot being 80 cents, essentially a 4/5 of a dollar. Predict the cost at 175 feet. Well, remember that's our x, so I just plugged that into my formula, found that to be $40. And predict the space you could get for $44. Well, I plugged in 44 for y, went ahead and added 100, multiplied by 5/4 in order to cancel our 4/5, and ended up with 180 square feet. Again, the big idea is taking 2 points and finding the equation of a line. We can then use that equation to predict future items. Well, a line of best fit is essentially that same idea. The difference is now we have a whole chart full of information. So this chart on the left tells us how much or how many years of experience 8 different employees of Technomatic have, and also what their hourly rate of pay is. Now it doesn't say anything about what job they have or other things. Some may be higher up technicians, or it doesn't tell us that. All we have is our basic information, and we're hoping to glean a formula or a pattern from this. Now notice when we plotted those points, they don't come out to a perfectly straight line, but that wouldn't stop us from at least trying to draw a line that's reasonably close to all of those points. And that's what line of best fit is. It's just a line that's going to be reasonably close to all of our data. So I usually try to draw my line so that some of my points are above the line and some of my points are below. If we're lucky, maybe we'll get a couple of points right on the line, but it's not necessary. That looks like a pretty good line to me. You may draw it a little bit differently, either a little flatter or a little bit higher on one end. That's fine. Lines of best fit are interpreted or up to whoever makes the line. All that matters is that we can judge a couple of points that are on the line. So looking at my line, first of all, we made a scatter plot. It was already on there for us. We drew our line of best fit. Now I want to find the equation for the line of best fit. Far more important than just being able to draw that line. So looking at my line, I noticed that I essentially went through the point 2, 8. So I'm going to use that. Even though it's not one of my pieces of data from my list, it looks like a good point that is on my red line. Also, I noticed that 1220 seems to be on my red line. And that was one of the points on my chart. Just happens to be there, doesn't necessarily need to be there. So now, again, take a second, take those 2 points, find your slope, and see if you can find the equation of the line using a slope-intercept form, y equals mx plus b. Alright, after finding my slope, it came out to 6/5. I went ahead and plugged in 1220 into my equation and found that my intercept is 5.5. So y equals 6/5 x plus 5.5 should be a good equation for that line of best fit. We can now predict the hourly rate of pay for a worker with 7 years of experience if we just plug in the fact that x would be 7 into our equation. So y equals 6/5 times 7 plus 5.5. Now, I'm going to go ahead and use a calculator just because I think that would be easiest. So 6/5 times 7 plus 5.5. And it comes out to about 13.9. So y equals $13.9 per hour. Alright, now that we have our pay scale figured out, we also want to talk about the idea of correlation. Any line of best fit, we want to know, first of all, does it have correlation? And second of all, is it a positive, a negative, or again, possibly no correlation? How does it relate to sort of a number we could compare to other lines of best fit? Correlation is just saying, do our x coordinates and our y coordinates seem to work together? So on our graph, you notice as x increases, as we move out to the right on our graph, sorry, I got the dog barking in the background here. As we move out to the right on our graph, our line seems to move upwards, which means that there is correlation. So now that we know that there is correlation, so we'll label that a yes, the question is, what type of correlation do we have? Is it a positive and negative correlation, and how does that relate to our numbers? One thing you want to remember is that positive correlation, or correlation close to a positive one, right, means that you have a fairly linear line with a positive slope. The closer to a straight line that it is, the closer to 1 that it will be. If it's not quite a straight line, it'll be a little bit less than 1. But if the slope is positive, if from left to right you're increasing, then we would say that we have a slope likely close to 1. If the slope is negative and your line is still reasonably straight, you're going to be close to -1. And the less close to a straight line that it is, such as the one at the bottom, the closer to 0 that you'll be, somewhere between -1 and 1. Or if it's just completely scattered, I don't even see where a straight line would really model the data at the bottom. Therefore, you're going to be really close to 0, or having likely no correlation. It's not really a linear relationship between what x and y are doing. They're just scattered all over the place. So looking back at our line, well, these points are reasonably straight. We've got a positive slope, so I would say that you're going to be reasonably close to 1. I hope that's a basic explanation of correlation for you. Also an easy way to come up with the equation of line of best fit. Good luck and have fun.